So hello everyone, you're tuned in to today's PIR live event. I'm your host for today, Scott Jones. Our guest today is Dr. Pete Hollings from Lakehead University. Dr. Hollings is a professor in the Geology department at Lakehead. Dr. Hollings' research focuses on whole rock geochemistry and petrology in the exploration of ore deposits. Dr. Hollings' research brings him to field locations that are very diverse, from Kirkland Lake, Ontario to Baguio District of the Philippines. So welcome to the event today, Dr. Hollings.
Hello, welcome.
So before we get started, I'd like to also welcome today's viewers who are watching the live stream. It's great to have you with us. And remember that if you have any questions throughout the half hour, you can tweet us at the hashtag AskPIR throughout the event today. If you have room in your tweet, also include your name, school, or city so we can give you a shout out. So I look forward to getting to some of those questions, but first I'll turn it over to Dr. Hollings, and he'll tell us a bit about his background and talk a bit about his research in geology. So go ahead, Dr. Hollings. Very good to have you with us today.
Thank you very much. So I guess my background is I grew up in England, in the UK. I did my undergraduate degree in geology there. And then I moved to Canada to study for my PhD in Saskatoon. After that, I lived in Australia for a couple of years, doing something we call a postdoctoral fellowship. And it was there I started really getting into working on ore deposits. I spent time working in South America, particularly in Chile, looking at a style of deposits that we call copper porphyry deposits. This is where we get most of the world's copper. You find them in these very large deposits located high in the Andes Mountains, so it was a really exciting area to go and do field work. I got to sort of walk around and hike around and collect rocks at sort of elevations from 3,000 to 5,000 meters, surrounded by amazing wildlife and amazing scenery. So that pretty much convinced me that that was what I wanted to do for my research career. So then I moved to Thunder Bay, which is where Lakehead is. And I've been here for close to 15 years now. And here at Lakehead, I've set up a fairly diverse research group. I look at mainly three different styles of mineral deposits and their relationship to the rocks they form in. Close to home here in Thunder Bay, I work on an area called the Mid-Continent Rift. And about 1 billion years ago, so that's 1,000 million years ago, North America tried to rift apart and split in two. And Lake Superior, in the middle of Canada there, is sort of the expression we have of that rift today. And associated with that rift, we get a type of deposit called nickel, copper, platinum group element, or PGE. So those are the sort of deposits where we get a lot of those metals from. And so I've had a lot of my students and myself working in this area, trying to understand these rocks, going out in Lake Superior on boats, sampling different outcrops, working in the bush up here. As I mentioned, I also do work on gold deposits, and that's what's taken me to places like Kirkland Lake, Red Lake, Pickle Lake, far northern Ontario, looking at some of the giant gold deposits we have in Canada. That includes the Red Lake Camp, which is Canada's biggest, and then Hemlo, which I think is Canada's #3 ore deposit. And they're all fairly close to Thunder Bay, so it's a fairly easy access to get to. They're active mines, so we get to go underground, interact with mine geologists, get a sense of what's going on, and try and understand how we accumulated all this metal in this one space on the planet. And then the third type of research I do is, again, I'm still looking at this type of deposit called copper porphyry deposits. And that takes me all over the world. In the last few years, I've been to Australia, Philippines, Chile, China, Mexico, Panama, all different places, looking at this same type of deposit and trying to understand how they form. So what unusual event occurs on the Earth thing to concentrate on this metal into a point where we can actually extract it and mine it and make money from it. And all of you out there who've got your smartphones or your computers or your iPads, we need those metals to make those things work. We can't manufacture anything. There's out there, if it can't be grown, it's got to be mined. And that's very true. So we need to find these metals. So me and my students, we go out and we try and understand how these deposits form, and we look for ways to help companies find more deposits elsewhere in different parts of the world. So it's a really interesting way to spend my life, spend my time. Working in different countries is always interesting, exciting. You get to meet all kinds of different people, experience different environments. Working in Panama a few years ago, we were in the middle of sort of this tropical rainforest. They have sort of 10 meters of rain coming down every year. And so seeing all the challenges that creates for mining companies and that creates for the geologists, the people I work with, was really interesting. And then you compare that to Chile, where we worked in the Atacama Desert, which was sort of the driest place on Earth, where in parts of there it hasn't rained for 100 years. Really different environments, really different places to work, but really exciting. I enjoy that aspect of my job quite a lot. What we're trying to do all the time is understand how these deposits form, how we get the metal where we do. And so we're looking at different ways, whether it's looking at the mineralization itself, that's the metal in the ground, or the surrounding rocks, to try and piece together a history of the events that led up to these things. So we know for some of the really big deposits in Chile that what we think is happening is that there are changes in the Earth's tectonic plates that triggers these mineralization events. And so we're trying to figure out ways to recognize those events in the geological record, because often we're looking for these deposits in very old rock, so we don't know exactly how they formed. So we have to be sort of forensic investigators, if you want, to try and figure out how we can piece together a story and make sense of how we can form these rocks.
It's very interesting. So your work obviously takes you all over the world. Do you know in advance, like before you go to these locations, what you're going to be finding there? Or is it some research that has to be done in advance to let you know where to go?
So we do a couple of things. One is we'll always try and find what other people have done in the area before us, and that means sort of going into the library and finding all the published research we can. We also try and work with local experts, whether they're the mine geologists or guys from the geological surveys in those areas who have a lot of local knowledge, and they can very much speed up our work. They get us into the right areas more quickly. But sometimes we've also just gone in sort of completely blind and just got on the ground and just started hiking around trying to figure out what's going on. That's the hard way to do it. It's the slow way. If we can work with people who know the area, then that's so much easier. It's always what we try and do.
Okay. And when you go with your group, how long are these excursions then? Are we talking months at a time, or?
It varies. For me, generally, I'm on the ground for 2 weeks to a month in different areas, trying to get projects going. But often my students will stay there for 2 to 3 months to sort of complete all the work they need to do for their research. So I'll go down with them, I'll get them started and get them established and know where they're going and talk to various people. And then I'll leave them with someone else. We never let people work alone, that's not safe, but they'll work with another student and do what they have to do to get all their work done. I had 2 students working up at Red Lake this summer, and they were up there for 6 weeks. They got to stay in a fishing camp and go out on quad bikes and boats and canoes. I think they had a pretty good summer, but they were out there collecting rocks, rain or shine, getting stuff done. So yeah, it varies from where these areas are. A lot of the research we do around Thunder Bay, we can drive to in a day. So we do that very quickly, very easily. Going further afield, if you're going down to Chile or Panama or Mexico, you want to make sure you get everything done in one hit. So you'll take a little bit longer to get it done right.
And I imagine you said your research group is very diverse, so you must need to take advantage of lots of different backgrounds and people with different disciplines, whether it's chemistry or physics or geology.
Yeah, so most of the students I work with are geology students, so they've done an undergraduate degree in geology, just because you need to be able to understand the rocks. But the larger research group as a whole, we have physicists, chemists, all different people. I work with groups. I also do some work looking at mine waste and how to remediate the tailings and the waste rock from mines to make it safe. And I'm doing some of that work with a biology professor here at Lakehead. He looks at sort of the plant and animal life. We look at the rocks and minerals, and we work together to try and come up with solutions to how this thing works. You know, one of the nice things about geology, I think, is you need to know a little bit of physics, a little bit of chemistry, a little bit of math. It sort of brings all the other sciences together, and that's one of the reasons, at least, I ended up in geology.
So I've got a few questions here. I'm just monitoring the Twitter feed. One
Okay.
looks like from Brent sitting right next to me, but so he says he's from Sudbury, Ontario, and he was told that the ore deposits in Sudbury are related to a meteor strike. Is that true?
It is true. About 1,800 million years ago, there was a meteor impact in what is now Sudbury, and it was a fairly big one. We think it was a 2 or 3 kilometer size impact ore, so a meteorite, hit the ground there and caused everything to melt. And we used to think that a lot of the metal in the ore deposits in Sudbury came from the meteorite, but the current thinking is it was just the impact of that meteorite caused everything to melt and concentrated all the metals around the deposit. What's interesting is a couple of years ago, some researchers up here in Thunder Bay found the ash debris flow from that impact in the rocks around Thunder Bay. So, and we now know that we can sort of figure out that that ash would have got from Sudbury to Thunder Bay, which is about a 8-10 hour drive, something like that, in about 60 seconds. So that sort of gives you some idea of the size and devastation that would have been caused by this thing.
Another question here from Anupreet Singh. Are there any precautions you must take when mining certain metals?
Well, I guess there's always, that's a really good question, actually. There's always precautions you have to take, and it depends on what you're mining. Mining is a fairly dangerous business, but the mining companies now have got much better in terms of managing safety and managing sort of the risk associated with mining. A lot of companies are going towards remote mining, so there are less people underground near the face. But you are using explosives to break apart rocks, and then you're sort of in areas where there's loose rocks. You have to be very careful. If you ever get to visit a mine site, they'll always make you wear steel-toed boots and a hard hat and safety glasses, so you're as safe as possible. Different metals, there are different risks. So uranium mining, which is something that we do in Canada in northern Saskatchewan, because it's uranium and there are issues of radioactivity, they sort of limit the amount of time geologists can spend near the rocks or miners can spend near the rocks. So it depends on the type of the metal. Things like, diamond mining or gold mining, the metals and the diamonds aren't inherently dangerous like it is with uranium, but there are the risks associated with the mining itself.
A very closely related question to that from Bobby Narwhal, who asks, how is mining safety in Canada different to mining in developing nations? For example, China and India.
It's very different. I've had opportunities. I've never been to India. I have been to mines in China, and they're not as rigorous in their safety protocols. So if you go, when I was at Hemlo last week doing some work, I had to go through a 45-minute induction period to make sure I knew about safety protocols. I was always dressed appropriately. They were very strictly controlled where I went. When we went to a mine in China, we had a hard hat on, but there was a lot less strict requirements. I was in the Philippines one time where they had sort of what they call artisanal mining, which is sort of small-scale local mining, guys trying to make a living, and that was just guys wearing shorts and a t-shirt and going underground with a shovel and pick, right? So it's very different. A lot of those developing countries are improving their safety considerably. China used to have one of the most dangerous and worst records for coal mining, but they've taken big steps recently to close some of the more dangerous mines and control those things. So I think it will catch up. It is going to take some time, I think, before they're at the same standards. When Canadian companies, though, go and mine overseas, so if you ever go to a Canadian mine in Africa or India or Chile or China, wherever, they then apply the same rules that they apply in Canada. So though in those cases there might be a local miner right next door that's run the old-fashioned way, but the Canadian miners introduce the same safety standards that they have in Canada. So they do a really good job of trying to keep everyone safe, and the mantra is everyone goes home at night, and things are getting much better. The mining industry is a lot safer than it used to be.
So you talked earlier about the utility of gold and silver and these type of minerals in modern technology. That being said, on your travels, have you ever had any unexpected discoveries? Have you ever found something that you didn't expect to see before you got there?
Unfortunately not. No, well, I shouldn't say that. So we've often, when we've come back and sort of analyzed the data we've collected, we've realized that maybe some of the rock types are unusual or atypical, but we didn't necessarily recognize that in the field. It took doing all the different analytical techniques we can apply. So no, generally when you go down, there's not many places on the planet that haven't had some kind of geological map. So you've got a rough idea what you're getting into. You've got the age of the rocks. You know, I'd love to say I'd gone down and discovered a gold deposit somewhere or a diamond deposit, but those are in very rare occurrences indeed. You know, the statistics for Northern Ontario are, I think, something like, you know, there's something like 10,000 mining claims, of which maybe one will ever become a mine, you know, in a given 20-year period. So there's a long way between finding mineralization on the ground and taking it to a mine, and unfortunately that's not something I've been lucky enough to do.
Just out of curiosity, is your work, like would the federal government take any interest in learning the history of certain areas, whether it be a natural park or something like that they can then convey that information to the public?
Yeah, so that happens quite a bit. So here in Ontario, we have what's called the Ontario Geological Survey, and they're responsible for producing the geological maps of Ontario. And then I work very closely with groups both based in Sudbury and based in Thunder Bay, trying to understand the regional geology and then communicate that information to the public. They've just published recently a highway guide for driving sort of along the north shore of Lake Superior, and we contributed to that to highlight some spots. I have worked with some national parks in the area and some provincial parks to help them upgrade their signage and their communications to the public to try and do that, and that's something we always try and do. The federal mappers are called the Geological Survey of Canada, and they map mainly in northern Canada because each of the provinces has their own provincial survey organization. But again, most university geologists will work with them and, you know, outreach to the community and engaging with community to make people understand how the planet works, what the geological hazards might be in the area where they live, and what things we have to worry about. Yeah.
So I got a couple of questions here along the same vein, asking about current job opportunities in the field of mining.
So right now is not a great time to be a miner or to be a geology student because metal prices have dropped. A lot of the mining companies are struggling. Saying that, there's still a lot of jobs for geologists working with geological survey organizations. A lot of work going in the environmental side. I think we graduated 12 students from the Lakehead Geology program last year, and as far as I know, 8 of them are currently working as geologists. So it's still not great. It's not as good as it was, say, 5 years ago when the mining industry and the exploration industry was booming, but there's still a lot of job potential out there. As a geologist, you could end up working on a mine site. You could end up working for a smaller company doing exploration. It could take you all around the world. Becoming an academic, working for the government surveys. There's all different paths and routes that people can take. It just depends where your interests lie and what you want to do.
So we talked a little bit about the government angle, but what about on the industry side? So if you find some gold or something that can be useful to certain technological companies, do you get in touch with them or?
So generally, I think the way it works in Ontario is most of the sort of the grassroots discoveries are either made by prospectors, so guys who just go out and walk through the bush and look for stuff. Or sometimes, you know, people coming in, they might come into the university with a sample and we can tell them what it is and help them identify it. And then again, in Ontario, we have this program called the Resident Geologist Program, and they have offices across Ontario, and they'll go in and they'll explain to you the steps of, you know, how do you stake a claim if this is something interesting. Perhaps you haven't got what you thought you've got. You know, you might have got pyrite, which looks like gold but is valueless, whereas gold obviously is really good. So those are sort of the early steps to do, I think, and some of the early things. And then the next step is basically you start exploring your property. You get involved with drilling, and that's beyond what the general public can do. And they start bringing in specialists, And then the bigger the deposit looks and the more exciting it looks, then the more likely it will be that a major mining company might get involved and think about then developing a mine in that area.
Okay, so you're quite often the first person on the scene, or the first.
Yeah, we get a fair few people coming through. Here in Thunder Bay, we get people coming in with specimens they think might be gold. We also get a lot of people coming in with stuff when they think they found a meteorite. That's quite a common thing people come into the university with. Unfortunately, many of them aren't meteorites. There are lots of things that can look like meteorites but not. But your local university can often help you do those early steps and try and identify what you found and tell you whether it's worth anything.
So we have another question here from Caveman Jat, and he's asking, where is Canada's greatest mining region?
Well, I'm in Northern Ontario, so I have to say Northern Ontario is Canada's greatest mining region. I'm a little biased, but we do have here in Northern Ontario, we have a lot of Canada's gold deposits. The Red Lake area is the biggest gold mine in Canada, and Hemlo's up there as well. There's also quite a bit of mining in British Columbia still. There's some stuff in northern Saskatchewan and the Flin Flon area, and then there's stuff out in Newfoundland. So it's scattered across, but in terms of sort of probably the biggest value mines, it probably is Northern Ontario with Red Lake. I'm sure there's people from other provinces that might disagree, but that's my take on it.
So getting back to, you go to a site, then you're working with the rocks. What's the actual process of separating the minerals and the interesting stuff from the rest of the rock? Can you speak a little bit to that?
Sure. So it depends what you're looking for and how you want to do it. If, for example, you found what you think is some gold in quartz veins, then it can be very simple, and you can almost just sort of break it up with a hammer, crush it. There's a whole bunch of TV shows up there where they show you doing sort of really basic crushing, and then you run it through water mills and separate the heavy gold because it's heavier and denser. With other metals, it can be more challenging to get them out, and depending on the size of the gold that you're looking for, or the copper, or whatever else, there are different processes. The first step is always crushing the rock. We have to crush it and break it. First, you blast it, and then you take those big chunks you get from the blast, and you crush them down into smaller and smaller pieces. And then from that crushed material, there are different physical, so maybe you can separate things with magnets, or chemical processes, so you can use different solvents or chemicals like cyanide or mercury to separate out the gold and extract them from those different processes. With diamonds, they use X-rays. The diamonds show up on X-rays, and so they can sort of identify them visually, and then they have sort of systems to robotically pick them out. So that always involves crushing, but then what you do after that depends very much on what you're trying to find.
Very interesting. And do you do all of this work at the site, or do you bring any of it back to Lakehead to analyze there?
So most of the research we do involves collecting the rocks and bringing them back to Lakehead, where we would then sort of crush them up and analyze them and want them. But there is some really interesting technology now where a lot of the really expensive analytical machines we used to have at universities, they're now available on site. So there's something called a portable XRF, and it sort of looks like a bit like a laser gun or something, and you can point it at the rock and it will tell you what the major element concentrations are, how much magnesium or silica and different components there are in the rock. So there are tools that are being developed to make it easier to collect information on site, but a lot of what we do still involves coming back and doing it back in the lab here at Lakehead.
So we have a couple more questions here. One from, we just talked about this one. One from Mel. What was the estimated mining revenue in 2014?
Oh, wow.
I don't know what she...
I don't know the Canadian number. I think in Ontario it was something like $10 billion, but that includes everything from gold, all the copper mines, but it also includes all the sort of aggregate mines where they mine sort of just sort of gravel and stuff for roads and material. I think that's about the right number, but it's quite a bit of money. It does make a fairly big contribution to Canada's economy. We're still what we call a resource-based economy. So when China's consuming metals, it impacts us because we are producers of those metals. So it's a big chunk. I'm not sure of the exact figure though for Canada.
Okay. So, current projects then. What's in the works for you at the moment then? What has you excited right now?
What's got me excited right now? Well, we've just started a new project looking at the Hemlo mine, which is a gold mine about 4 hours east of Thunder Bay. It's a very unusual deposit. It's been described as many different things over the years, so we're going to have one more try at trying to figure it out. So that's got me pretty excited. And then I have ongoing collaborations with a group that's going to be taking me overseas, possibly back down to South America or Sweden in the next 6 months, something like that, to do some more work out there. So again, that sort of thing is always fun and exciting.
One more question here from Amanda Banerjee. Are there any newly discovered metals? Do you ever discover anything new?
Me personally, no. I haven't had that fortune. We haven't found a new metal for a long time. Like, they haven't added anything to the periodic table. I think the most exciting probably mineral deposit, so metal discovery in Canada recently, was something called the Ring of Fire, which is quite a long way north of Thunder Bay in an area called the James Bay Lowlands. So if you know where Hudson Bay is on a map of Canada, it's just sort of in from there. And it's a very large chromite deposit. So chrome is a metal we use to make stainless steel, and amongst other things. So it's a very big deposit. It's very exciting, but it's also very remote. And I think in the next 5-10 years, we're going to see efforts to develop that. So it's probably one of the more exciting discoveries across Canada in the last few years.
Very good. So I think we're almost nearing the end of our time here. It was very good to listen to what you had to say, Dr. Hollings. I'm sure based on the Twitter response we've been getting, everyone was very excited and stimulated by what you had to say. So I think that's all the time we have for today. I'd like to say thank you again to all of our viewers, and of course to you, Dr. Hollings, for answering our questions and sharing your expertise with us. Just as a reminder to our viewers that the next PIR live event will be Tuesday, November 3rd at 1 p.m. Eastern, when Dr. Graydon Raymer from Nipissing University will join us to discuss exercise physiology and heart health. All right, so thanks again, Dr. Hollings.
Been my pleasure.
All right, bye for now, everyone.